Hey guys, it's Dr. Franklin and I'm back again with the frequency table tutorial. If you'll look at the top of this video, you'll notice that I have a series of numbers listed out. The first thing that I would recommend that you do in terms of putting together your frequency table is to go ahead and list these numbers out in numerical order, going from the left to the right of your page. So I'll do that on the whiteboard here. I have 1 5, I have 2 6s, I have 2 8s, I have 3 9s, and I have 2 10s. All right, so once you've listed out your numbers in numerical order, I would recommend that you create an X column. In this X column, what you'll do is list the appearance of the scores within your data set in descending order from top to the bottom of your page. So start with 10, now go 9, 8. I'll throw a 7 in there just for continuity's sake. 6 and a 5. Okay, notice how the numbers are listed in descending order going from the top to the bottom of my page. Now you could list them in ascending order going from the top to the bottom of your page. There's no hard fast way that you need to do this. The important thing is that you want to make sure that you're being accurate and that you're interpreting the information properly. Next column that you'll create will be a frequency column. This is the column in which you will indicate how many times 10 shows up in your data set. You'll indicate how many times 9 shows up in your data set. You'll indicate how many times, okay, all right, it's getting a little redundant here, right? So 10 shows up twice, so we'll put a 2 there. 9 shows up 3 times, 8 shows up 2 times, 7 shows up 0 times, and I just put a 7 in my raw score column because I like equal intervals. 6 shows up 2 times, and 5 shows up once. Okay, very basic frequency table. One column has the indication of the scores, the other column has the frequency in which the scores appear. Next column that you can create is a proportion column. The proportion column lists the frequency in which a score appears in decimal format. You can think of the formula for that as F over N. F stands for frequency for a particular raw score. So for 10, that would be 2. And then N means sample size. And we know that we're working with a sample size of 10. So applying this equation to what we need to calculate for the occurrence of the score 10 would look like this. We have 2 over 10, and then if we divide 2 by 10, we'll end up with 0.20. 3 over 10 would give us 0.30. 2 over 10, which we've already done, would give us 0.20. 0 over 10 would give us 0. 2 over 10 would give us 0.20, and then 1 over 10 would give us 0.10. Now, how do you know if you're on the right track? Well, you should be able to add up all of your proportions in decimal format and get a number that is very much close to 1. I say that it may be very close to 1 because depending on how you round it and depending on if you have discrete values within your data set, you may get a number that's slightly below 1 or slightly over 1. Okay, so the important thing is, folks, that when you're rounding with continuous values, make sure that you're being consistent in your rounding. So if you're rounding to the tenths place with one particular numeric, make sure you're doing it with all of your numerics. If you're rounding to the hundredths place with one particular numeric, make sure you're doing it with all of your numerics. Okay, make sure that consistency is there, and also make sure that you're interpreting the information correctly. Now let's move forward and do a percentage column. And a simple way to do a percentage column, the percentage column simply lists out the frequency in which a score appears in percentage format. A simple way to do it is just take the decimal, okay, and bring it over to your percentage column, and take the decimal point 2 spaces to your right, okay, and that will yield you a 20%. You can do the same thing with the rest of them. 2 places to your right, 30%, 0.20 yield you 20%, 0, 0%, 0.20, 20%, and then finally 0.10, 10%. Okay. Again, how do you know if you're on the right track? Add up all of your percentages, and they should get you somewhere close to 100%, if not 100%. Okay. Another way that you can calculate percentages is simply by taking the proportion for each particular score and multiplying it by 100. Okay. And they will yield you the same whole number, which you can simply add a percentage mark to. Okay. So 3 different ways to skin a cat. Not that anyone really wants to skin a cat. That's something that is definitely not in my bucket list of things to do before I die. But you got options here, okay, folks? And with your calculators, you can even put in percentages with these different equations I've given you to give you the proper numbers for this particular column. Okay. Now, since we've gotten this far, let's go ahead and put these numerics into a histogram. And a histogram has a similar setup to a bar graph, but the big difference is on our x-axis, we'll have the occurrence of the scores, or raw scores, whereas within a bar graph, we would usually have labels or categorical information. In other words, the bar graph is more so used for nominal data. Here we are working with data that appears to be either interval or ratio. I haven't defined what these numbers represent, so we can't definitively say which one it represents. Let's go ahead and list out our raw scores on our x-axis. We got 5, 6, I'll put a 7 again for continuity's sake, 8, 9, and 10. On our y-axis, we'll list out frequency, 1, 2, 3, 4, 5, and then let's stop at 6 since it appears that our highest frequency is 3. Okay, now on a histogram, the bars are spread out in such a way that the real limits of each whole number are touched. So the width of the bar is going to be very much contingent on the real limits of the number, which is 0.5 below a whole number or 0.5 above a whole number. And the height of the bar is going to reach up to its frequency. So for 5, that number shows up 1 time in our data set. So that's the type of bar we'll create. And for 6, that number shows up twice. So we'll actually start that bar from its lower real limit and put that up to 2, and then stretch it over to go to its upper real limit, which is 6. 7 had no frequency whatsoever, so we won't touch that. 8 goes up to 2. 9 goes up to 3. And then 10 goes to 2. In a bar graph, the bars do not touch, but in a histogram, they do, okay? Because of the recognition of the real limits for each discrete value within a data set. If you wanted to take this histogram and turn it into a line graph, all you would have to do is plot the midpoint of each bar. And then you could simply connect your dots. After you connect your dots, you could simply eliminate the bars and you would have a line graph that would give you relevant information as it pertains to frequency and the trend of the data.